The paper of the day is Apache Calcite, a foundational framework for optimized query processing over heterogeneous data sources. Apache Calcite is a foundational software framework that provides a query processing, optimization, and query language support to many popular open source data processing systems such as Apache Hive, Apache Storm, Apache Flink, Droid, and MapD. The goal of this paper is to formally introduce Calcite to the broader research community, briefly presents its history, and describe its architecture, features, functionality, and patterns for adoption. Calcite's architecture consists of a modular and extensible query optimizer with hundreds of built-in optimization rules, a query processor capable of processing a variety of query languages, an adapter architecture designed for extensibility and support for heterogeneous data models and stores, that is relational, semi-structured, streaming, and geospatial. This flexible, embeddable, and extensible architecture is what makes Calcite an attractive choice for adoption in big data frameworks. It is an active project that continues to introduce support for the new types of data sources, query languages, and approaches to query processing and optimization. The following features have contributed to Calcite's wide adoption in the open source community and industry. Open source friendliness. Many of the major data processing platforms of the last decade have been either open source or largely based on open source. Multiple data models. Calcite provides support for query optimization and query languages using both streaming and conventional data processing paradigms. Calcite treats streams as time-ordered sets of records or events that are not persisted to the disk as they would be in conventional data processing systems. Flexible query optimizer. Each component of the optimizer is pluggable and extensible, ranging from rules to cost models. Cross-system support. The Calcite framework can run and optimize queries across multiple query processing systems and database backends. Reliability. Calcite is reliable as its wide adoption over many years has led to exhaustive testing of the platform. Support for SQL and its extensions. Many systems do not provide their own query language but rather refer to relying on existing ones such as SQL. Though Calcite contains a performance testing module, it does not evaluate query execution. It would be useful to assess the performance of systems built with Calcite. For example, they could compare the performance of Calcite with similar frameworks. Unfortunately, it might be difficult to craft fair comparisons. Moreover, to assess the performance of Calcite-based systems, they needed to consider two distinct use cases. First, Calcite can be used either as part of the single system as a tool to accelerate the construction of such a system, or the more difficult task of combining several distinct systems as a common layer. Now, emerging data management practices and associated analytical uses of data continue to evolve towards an increasingly diverse and heterogeneous spectrum of scenarios. At the same time, relational data sources accessed through SQL remain an essential means to how enterprises work with data. In this somewhat dichotomous space, Calcite plays a unique role with its strong support for both traditional, conventional data processing and for its support of other data sources, including those with semi-structured, streaming, and geospatial models. In addition, Calcite's design philosophy with a focus on flexibility, adaptivity, and extensibility has been another factor in Calcite becoming the most widely adopted query optimizer used in large number of open source frameworks. Calcite's dynamic and flexible query optimizer and its adapter architecture allows it to be embedded selectively by a variety of data management frameworks such as Hive, Drill, MapD, and Flink. Calcite's support for heterogeneous data processing as well as for extended set of relational functions will continue to improve in both functionality and performance. Now let's talk PS score for this paper. Overall, this paper is a decent read, so it gets a 9 out of 10 on readability. With 10 pages long, it scores 9 out of 10 on length. It's an analysis of an existing system with pretty good description, so that makes it 9 out of 10. Its industry value and learning meter is pretty high, so it gets 9 out of 10 on each. Overall PS score is 9 out of 10.